Hello, eighth graders. Today we are still working on equations with variables on both sides, but we're going to see some kind of different things that come up and make sure we know how to deal with them. So you need page 47. Page 47, make sure you have page 47, pens, pencils, whatever you need to take notes. Here we go. All right, these notes are called equations with variables on both sides. Special cases, special things are going to happen in these notes. And to show ourselves what that means, let's start with a little model like we started in our last notes. Remember, these are X tiles, okay, just like our bags of chocolates. And these are 1 tiles. And we have learned and seen that if you have an equivalent amount on both sides of the equation, those pieces will cancel out, which is actually just the additive inverse, those things turning to 0. So look what happens on this one. First of all, let's write for ourselves over here the equation that this is representing. This is the equal sign. This is where it cuts down the middle. So on this half, we have 2 x's and we have 8 1's. On that side of the equation. On this side of the equation, we have 2 x's and we have 4 1's. So that, first of all, is the algebraic equation that this model is representing, because we're just showing this model one time to see what's going on with it. But most of the time what you will be given is the algebraic equation. What do you notice about the solution of this equation? Well, maybe nothing yet. But if we start doing what we were doing in the other model and we start canceling things and showing what's going on, we see that these 2 x's would 0 out with those 2 x's with the additive inverse. And we see that these 4 1's would also 0 out with those 4 1's with the additive inverse. And something very strange just happened there, didn't it? What we ended up with is 4 1's over here and 0 1's over here and 0 x's. All of the x's canceled out with the additive inverse. So how do I solve this equation if the variable is gone? Well, the fact is right here, not only did the x's disappear, but what we have left here is some constants that do not match up. This equation is a false equation because we are left with 4 on this side and 0 on this side. This is like that chocolate situation where you went, there's no way those could ever be equal. And what that means for this particular scenario is that there cannot be a solution. If your variables cancel and the constants that you are left with don't make any sense, are not actually equivalent, then that means the equation that you started with doesn't make any sense and can't ever be equivalent. And that means there is no solution. So that leads us to this middle section of our notes here. The fact is there's actually 3 different scenarios that you can run into. And when we say special cases, this is what we're talking about. Sometimes some kind of strange things happen when we try to solve an equation. This scenario is not the special case. This scenario is not the weird one where strange things happen. This is precisely what we are used to happening. So you will get one solution quite regularly. So what happens? What does that look like? How will we know we have one solution? Well, the short answer is that things will just work out like they normally do. But the way that you really recognize it is that the variables do not cancel on both sides. So basically, if you have a variable left, solve for it. And when you solve for it, you'll come down to some kind of answer that looks like x equals something, right? That means you had a variable left on one side, and so you solve for it. X equals something, okay? Now, what that means is for each of these, the variables will cancel on both sides. So variables cancel on both sides. That's precisely what happened up here. We had 2x over here and 2x over here. And if I would have done the algebra up here, if I would have gone, okay, I'm going to cancel and I'm going to turn this to 0, then you would have come over here and you would have went, oh, wait a second. This turns to 0 and this turns to 0. That's what we mean by the variables canceling on both sides. That will happen in this scenario. That will also happen in this scenario. So obviously we're going to have to write something else in order to verify the difference between these two. So the variables will cancel on both sides in no solution. The variables will cancel on both sides with this option as well. But what you're left with will be different. Okay, so you will know you have no solution if the variables cancel and you end up with a false equation. So if the variables cancel on both sides and the equation that you're left with is false, if the variables cancel on both sides and you're left with something that's false, like 4 equals 0, no, it doesn't. If you're left with a false equation, then you know you have no solution. So can you guess what will happen on this one? Well, what's the opposite of a false equation? A true one. And if you're like, what does she mean? What is she talking about? I don't understand what she's saying. Just say, I don't understand what she's saying yet. And as we look through a few examples, it will hopefully become clear to you. So the first thing you need to know and make sure that your brain is understanding right now is that there are 3 situations that could happen when you have variables on both sides. You could have the normal situation where you get a variable left on one side and you just solve for it, you finish your inverse operations and you get an answer, x equals 5, one solution, you're done. Or now we have these special cases as well. Sometimes you have no solution and sometimes you have infinite solutions. And to make sure we're really clear on what all this means and how this all plays out, let's go through these examples here. Okay, question number 3. We are going to use all the stuff we know about equations now and bring it together to solve this equation with variables on both sides. That includes if there is a cleanup step. And if you don't know what I mean by a cleanup step, that's where we simplify things first. For example, this side doesn't have anything to simplify. However, this side I can distribute. Distributive property. 2 times x is 2x, and 2 times -5 is -10. Now, a lot of you can recognize right now what's going to happen, and that's great if you can see that. But here's the nice thing, if you don't notice and you're just going through the motions, you're like, yeah, doing my algebra here, then you would start, you'd say, okay, I've got variables on both sides, so I need to zero one of them out. So you go, okay, minus 2x, minus 2x. Zero that out, and then right here would be the moment that you'd realize, oh my goodness, it cancels on both sides. That means we can't have one solution. That means we're not in this very regular normal scenario that we're used to. You can't finish solving for a variable if all of your variables went away. I'm in one of these 2 scenarios now because the variables just canceled on both sides. So the question is, which one? Well, now it's very important that you look at what is left. What's left over here is -5, and what's left over here is -10, and there's no more variables. And the fact is, this equation is not true. That should make sense to you because how could you have 2 times some number and then subtract 5 from it and then do 2 times that exact same number but subtract 10 from it and have those 2 halves equal to each other? It's not going to happen. You can plug x values into this equation all day long and you will never find something that makes both sides equal. So we come down here and we say, this is a no solution scenario. Once again, because the variables canceled on both sides, and what we were left with was a false equation. That's never going to be true. No solution. Okay, let's try this again. Over here to number 4. Okay, again, I see some cleanup. Do you remember how this is really a -1 in front of the parentheses there? And then this is the point where some students want to go 5 minus 1 and tell me that that's 4. Don't do that because of this little thing we have called PEMDAS, the order of operations. You are not allowed to subtract those because you have to multiply first. That doesn't make any sense to subtract right there. So I'm going to do 5. I'm going to copy that because I'm not doing anything with it. And now I'm going to multiply by -1. -1 times 4 is -4a. -1 times 8 is -8. Equals, now I'm just going to write this side, 5 minus 4a minus 8. You might notice something about the left-hand side and the right-hand side of this equation right now. And if you do notice that something, It's going to help you understand why what is about to happen is about to happen. I'm going to clean this up a little further, okay? 5 minus 8, those are what we call like terms, and they can be put together. That's negative 4a minus 3. 5 minus 8, that's negative 4a minus 3. What do you think this means about this particular equation? Well, watch what happens if you just start the algebra. Plus 4a plus 4a. Oh my goodness, I just canceled the variables on both sides. That's not a thing that's supposed to happen if I can just get a solution to this equation. But let's look at what's left this time. This time I have negative 3 equals negative 3. How often is that true? Always. That's always true. Negative 3 is equal to negative 3. That is just an always true statement. And that's what we mean by this scenario up here. The variables cancel on both sides, and then what you're left with is totally true all the time. There's no x to even be a variable. It's just always true. And this scenario means that there are infinite solutions. And what that is saying is that it doesn't matter what I pick for A. If I plug in anything, it will always work. So over here in this scenario, no solution means you can pick variable values all day long and it will never work. This scenario means you can pick variable values all day long and everything will work. Which should make sense to you because the left-hand side ended up being totally equivalent to the right-hand side the whole time. So that means that this is mathematically equivalent to this side no matter what A is. Okay, let's keep going. Make sure we understand what we're doing on the rest of these. Number 5, let's do some cleanup again, which I was using my green, oh, I found it. Okay, so this side has some combining like terms I can do. 3v plus 2v is 5v plus 10. Just doing some cleanup. Those are not inverse operations, so I'm just doing it on one side of the equation. Distributive property, 5 times 2 and 5 times v. I hope you get to a point where you can just recognize what's going on there. But just to prove it to yourself, watch what happens if I start the algebra here. I have variables on both sides, so I'm turning one of them to 0. Oh my goodness, in doing so, I turned them both into 0. The variables just canceled on both sides, and I am left with a true equation. That means this particular equation has infinite solutions. Everything will work. That's what it means. Everything is a solution to this equation. Everything makes it true. All right, let's look at number 6. Let's do some cleanup here. Distribute, distribute. This side still says 5x. This side says 2x minus 18. Are the variables going to cancel on both sides of this one? Well, no, because I have 5x's over here and 2x's over here, and that's a totally different number of x's, so they're not all going to cancel. So this is a normal situation. Here we go. I'm going to zero these out, and then whatever I do to one side, I have to do to the other side. And this is what we mean by the variables do not cancel on both sides. They canceled on one side because that's the whole point of this process, is to get all the variables to one side so I can solve for it. But look, 5x minus 2x leaves me with some x's, 3 of them in fact. And if I have some x's left, well then I can solve for x. Don't get too excited about always just stopping and writing no solution and infinite solutions. Students always want to do that. They start writing no solution and infinite solution on everything. Most things you can still solve. So I keep going. Divide by 3, and x equals negative 6. My variables did not cancel. I finished this thing. I found a solution. That is our very normal one solution scenario. Again, don't just assume everything is no solution or infinite. You guys get a little too excited about those options. You can still totally solve a lot of stuff. All right, last 2. Here we go. Number 7, let's clean this up. Distribute. 6a minus 24. Distribute. 6a minus 24. Do you see what's going to happen on this one? Minus 6a minus 6a. The variables canceled and the equation I am left with is totally always true. Infinite solutions. Again, you'll get to a point, and hopefully you're starting to see, I didn't even necessarily need to write the minus 6a to see what's going on. But in case you're not noticing and paying attention, then go through the algebra and you'll see what happens. Number 8. Take a look at this one and tell me right away. Can you tell before I even do anything if I'm going to have one solution, no solution, or infinite solutions? I hope you can tell that this is going to have one solution. Do you know how I can tell that this is going to have one solution? Because I have a different number of variables on the two sides of the equation. If the number of variables on the left and the right are different from each other, you're going to have a variable left and you're going to be able to solve for it. Okay, so I'm going to zero out this variable. And when I come over here and write that over here, here's what I see. They zeroed out here, but I totally have variables left over here. One of them, in fact, because 3x minus 2x is 1x. Copy the minus 12, that's still over there. And now I go, oh, I need to zero this out. And this is the moment that students go, oh, Ms. McGowan, this is totally no solution because look, those both canceled. Yeah, but are those variables? No, they're constants, they're numbers. 12 minus 12 is 0, but I still have an x left, so 0 is simply my solution. It's totally a valid solution, it's just the only number that works in this equation, but it is a solution. There is one solution to this. That solution happens to be 0 because the variables didn't cancel. All right, so we've got to be aware of these situations, no solution, one solution, or infinite solutions. You're going to practice some of those. Some of them will show up in your Canvas quiz today, so watch out for them.